Today let's discuss about the backward propagation. In my previous video I have uploaded what is backward propagation or what is forward propagation. Okay, so here suppose this is my neural network. So and these are the structure or the network for forward propagation. In this I have put up all the input layers, the parameters, hidden layers, output layers. Say for the input layer, so these are, let's consider this as an input layer. There are two inputs, x1, x2, x1, x2, this value, and the weights w1, w11, w12, w21, w22, and the corresponding value 1.7, zero point 0.3, 2.5, 0.7 are all here. Okay, and the summation function h, let's denote it by h1 and h2, is here 2.75, 0.70. So in I've considered bias as a 0, so let's just ignore the bias. So this is summation. Then use the sigmoid activation function on this summation, you will get the f of h1 and f of h2, which is here for h1, and this is f of h2. Similarly for the output layer, these are the weights wh1, wh2, corresponding value 2.2, 0.9, it's here 2.2, 0.9 here. So the summation function of this layer gives the value 2.67, and the activation of the summation, which is sigmoid we are using, it gives this value. So here I read sum up to two digits. Okay, output is 0.94. Say suppose the target value we input is 0.5, but we are getting 0.9. Then we say the error is this. Error is calculated using this formula, 1 by 2 of target minus out whole square. And say we have used the learning rate nu equal to 0.01. So this is for the forward propagation. What do we do? How is the backward propagation happen? So it's nothing but in the backward propagation what we do is from here, starting from the error, using the error from here, we try to update wh1, wh2, we update all the weights w11, w12, w21, w22, we'll update all these weights and then we run the network again, we execute the network again, and we get the output. Okay, we we change the value in such a way that the error is reduced and the output is going, it goes nearer and nearer to our target value. Okay, so how is this weights calculated? So w weights 1 to 2, suppose this is my weights in the forward propagation. So let's calculate, how do we calculate the weights in this weights for wh1. Say let's, so we have the input here, so let's calculate all these weights. Okay, so what is my new weights? New weight is all weights. From the all weights, either you add or subtract. Okay, probably we give the formula as a subtract. Okay, so it's given by wh1, this value, minus new, this is my learning rate, and this is a error with respect to weights wh1. Okay, so wh1 we know it, new we know it, learning rate, this is a parameters, you can change the, either you can reduce or increase the learning rate. So how do we calculate this? D error by dwh1. So let's calculate this. Okay, we need to find this, we know wh1 and n, so we need to find the error by dwh1. So using a chain reaction in the sense that, say this is error here, this error is dependent on, say this is a output, the error is dependent on the output, and it's further dependent on the summation, and this again depends on width. So if you go by this is the output, error is here, is dependent on this output, and then the summation, and then again depend on this. So there is a chain of interdependency. So they call it like, this can be further split using chain reaction into this, d error by d out, then uh, d out by do, then do by wh1. Okay, so this is something like a chain. Okay, so it can be split up into this, but these are the known components. So let's just check what is what is the first component. The first component is this one. How do we calculate this? What is the error? Error is, we have these formulas. Okay, we need to substitute. Let's substitute this and then find the differentiation. So we substitute formula is related to the f of 0. Okay, f of 0 is the output. Okay, which is the out. Okay, right. mm, then so I think there is a mistake here. This should be out actually. mm. So this, instead of 0, it should be out. So if you do the differentiation, you will get this 2 half target minus output 2 minus 1. So further we reduce to target minus out into minus 1. So it will swap, it will be out minus target. So what is my out, what is my target? We have your out value here, you have your target value here, we get this value. So we get the first component. Let's go and check the second component, d out by do. Okay, so the second component is d out by do. So what is my d out? D out is this, which is in formulas is a sigmoid function. Okay, so we substitute with the sigmoid function with out. So differentiation of this sigmoid function will give this value, out 1 minus out. So we know the out, we substitute the values, we get this. Then let's take the third component. We have this third component here, do by dwh1. What is my do? Do is a sum, is a summation of this with the inputs from here. Okay, so f of h1, this is f of h1 into w of h1 plus f of h2 plus w of h2. Okay, I ignore the biases for the sake of simplicity. We need to have the bias here, but it's not going to affect once you do the differentiation. So this in turns will get h1. So this value, you will get this value, and this will be 0 because this will be 0. Okay, then we substitute the value f of h1. What is this value? F of h1 is 0.94. So we have all the three components. Then we can derive this, the error by dwh1. So here we have all the three components. We know this and we know new. Then we substitute the values. What is my output? 2.199. So this value will be 2.199. Okay, similarly we can get this value. The only difference here is wh2. Okay, the rest is going to be same for if you want to calculate wh2 new, it's going to be basically going to be same, only this part is different. Okay, only this part is different. So probably this will be 0 and you will remain with this, and you will get this value. Okay, you get this value. So only this value is different while calculating WH2 new. Okay, so then the next we need to calculate this WH W11 W12 W21 W22. Okay, see here, this is, I just give the I just output the calculation because we are going to use some of the uh, outputs. So here let's see, we calculate. Okay, where is my this thing? So we want to calculate this W11. Okay, so W11 equal to W11 new equal to W11 minus new into the error by the W11. So how do we separate this for the split using chain reaction? So this will be more actually. Yeah, one, two, three, four, five components. Why five components? Because from the error you have this one component here, you have another component here. Okay, you have one component, another component, do by dh1, do this output by this one. Am I correct? Do by the, yes, this output with this, and then here again, here one more, and then from here it goes here. Okay, so the chain of reaction is a chain rule is like this. Okay, this longer, but we already know this, the first two component, first and second component we already know. So we can substitute this value, the first, then we find out the third component here. Third component do is basically is a summation function. Okay, so we split the summation function f of h1 wh1 f of h2 wh2, then d of f of h1. Right, this is I need to change in this symbol, not d. Then when we substitute the value, we have this. Okay, I mean when we calculate, we have this value, so it's 2.2. Then the next fourth component is here, f of h1. Okay, what is f of h1? Is a sigmoid function. This is a sigmoid, we substitute the sigmoid, and this h1 is a variable. Then we have this, and we substitute this, so this is the final output for the fourth component. Then for the fifth component, h1 is summation function. Okay, so we split the summation, we substitute the summation values, then we evaluate, then we get this. So now we have all the five components. These five components we substitute here. W11 we know, new, and then we substitute all the five components. Then what do we have? 1.699. Similarly, we do for W12. It's only the W12. If we from here comes here, here comes here, not here. Probably W12, right? If you want to calculate W12, if we come here, in the bottom node, and comes here W12, then it will come here. This. Okay. So we see this is the value we get. Similarly, W21, so it becomes same in this line, then here, then here, here, here. Okay, same thing. W22, you come here, here, here. Okay, so we have this W21 value. Similarly, W22, we have this value. Then at the end we have W11, W12, W21, W22, WH1 new, WH2 new. Let's substitute all these values. So this is the first forward, this was for the forward propagation, and in the backward propagation we substitute all these values, weights all these values, and then we evaluate. So once we have this input x1 x2 w1 1 w1 2 2 1 2 2, we can calculate the summation. From the summation, is this yeah, summation h1 summation h2, we can calculate. From this we can calculate the activation function. Then the weight we substitute, we can calculate the summation of the output layers, then apply the activation function, we get it. So here a little bit, so the value is supposed to be 5.5, but it's 0.9, it should decrease. So when you see the value will be decreasing here, 5935.4, 935.2. Okay, so it slowly should decrease and should be near to 5. Okay, so this learning rate is where I will show one Excel sheet. uh, where is my presentation? You see, this is a learning rate. You can create an Excel sheet using this. So now my error, now my output is 935.26. If you increase the learning rate, the difference will be more, and then it will so the conversions will be faster. Okay, since the gap is very high, zero point 0.5 and zero point 0.9. So you see the value changes to 9351. Okay, so this is a function of learning rate. Okay, that's all for me. Thank you.